Hello, and here is the next edition in the podcast. We're talking about section 4.3, which is focusing on two different ways to prove triangles congruent, which would be ASA, angle side angle, and angle angle side. They are very much related to each other, but the key difference is talking about where the side is located. So if the side is located in the middle, in between the two angles, then it's angle side angle. If the side is not, then it is away from the angles. It would not be. It will be angle, angle side. Here is a great visual for some of you visual learners out there. So again, as I mentioned earlier, here we have that side being right in between, in the middle between the angles. And same thing here. Here on angle, angle side, notice again that the side is off somewhere else. It is not in the middle between the two angles. So hopefully you can see the difference. We will incorporate those again with SSS in SAS as well. So you will still see some of those lovely buddies. However, we do not have anything that proves congruent triangles that make this combination of SSA or ASS, which is called the donkey theorem. So again, just as a reminder, if there's anything that spells a naughty word, forwards or backwards, then therefore that is not a way to prove triangles are congruent. And again, I do have this website here, so this is a legitimate site that I had this information from. So we're going to get down into the different methods and talk about why are these triangles congruent, and then incorporate some proofs, and then that will be the end of the podcast. And then the next podcast in this series, we'll talk about CPCTC. Okay, so for number one, again, make sure you have your notes out so they can correspond to that. You do have a reflexive side. Remember, we can assume reflexive and vertical angles. So for number one, we do have two pairs of sides and one angle. So if it's anything, it's going to be SAS. However, the angle needs to be between the two sides, and it's not. It's off somewhere else. So this spells angle, side, side. So therefore, when it spells something naughty, it's a none. In number two, we have two pairs of angles being equal and a pair of sides. That would be angle, angle, side, angle, angle, side. For three, we don't have enough information until we look at it and say, oh, these vertical angles have to be equal. So I'm going to mark them equal in the picture. And then now take a look at it. So angle, angle, and again, the side is not in between the two angles, so it would be angle, angle, side. Number four, they share a side, again, reflexive, two pairs of sides and an angle, so side, angle, side. Make sure you check both sides of the triangle, because again, sometimes one side can be SAS and the other one might not be. 5 also has a reflexive side, and we're going to have an angle, the side that they share, and an angle. So this would be ASA. So we're really going to practice on our different forms of triangles and why are they congruent. Okay, for the next page, we have 3 pairs of sides equal. This is a blast from the past from section 4.2. This would be SSS. 7, this is SAS for the left triangle, but if you look at the right triangle, the angle's in the wrong position, so it spells something naughty. So if one of them spells something naughty, that's a none. Number 8, we have some vertical angles we can assume. So therefore we can put those in, and then this would be angle, angle, side. Now to get us ready for proofs, we need to kind of write and figure out what additional information we need to have. So since we're trying to prove angle, angle, side, notice that they gave us 2 pairs of angles. So I don't need the angles. What I do need is the side. However, the side cannot be between, in the middle, between the angles given. So one possibility could be right here, that VX would be congruent to GI. But since it's an AAS, there could be another answer. Instead of this side being equal to this side, you also could have had this side equal to this side. So we could have had WX, which would have been congruent to HI. So this one has two possible answers. For the next one, number 10, we're trying to prove ASA. It looks like they only gave us an angle. However, they did give us a side reflexive. So make sure, again, you use that hidden information. So we need an angle. And not just any angle, it's got to be the angle next to the side. So then that's forcing these two angles to be equal. We can't just say angle A is congruent to angle A, so you do have to use the three-letter name. So CAB, CAB, and then that would be congruent to TAB, TAB. And that would be enough to prove ASA. So let's jump into the proofs and finish up the podcast. So here we have our lovely stuff. Remember, in a two column, we start with writing our given. So angle M is congruent to angle K, and we also have that WM is parallel to RK, and that's going to be given. We basically only have a pair of angles in here. So why are they going to give me parallel? Well, I'm going to show you that in a minute. So again, look at your pictures. See if you can assume anything. And when I mean assuming, I mean vertical angles or a reflexive side. So this one has a reflexive side. You need to say that. What reflexive means, again, is that you have that same side in both triangles. So WR is congruent to WR, and that's reflexive. Okay, now, why would they give me parallel lines? Well, they want you to find some angles that are equal. And in a triangle, it's always going to be your lovely alternate interior angles. So that's going to be this one that makes a Z this way. So you're going to have this part of angle W and this part of angle R. Can't just call it R and W because, again, there's more than one angle there. So I'm going to call it angle MWR is congruent to angle and then KRW. And again, since the lines are parallel, therefore those alternate interior angles are congruent. If you want to look up from the last chapter on the postulates, feel free to do that. I am unsure of what theorem number it is. I think it's theorem 3.1, but I'm not quite sure. And then finally, for number 4, we now have enough information to say that the triangles are equal. So WMR is congruent to triangle RKW. And then the reason why would be angle, angle, side. Done with the proof. 4 steps. Okay, one last proof before we close. So again, start out with your given. Angle S is congruent to angle Q, and RP bisects angle SRQ. So we're going to put that in there. Now, I don't like that in the picture. It's already got this angle marked as equal. And the reason they know that is because they did a definition of bisect. So we really need to say that those angles are equal. So even though it's marked in the picture, we need to state it. So angle SRP is congruent to angle QRP. And again, definition of bisect. And then I've got that marked. Hopefully you can see the reflexive in here. So PR is congruent to PR. And that is reflexive again. And then finally, we have the triangles congruent. So a triangle SRP is congruent to triangle QRP. And again, the reason for that one, if you look at it, angle, angle, side. And that concludes our podcast about angle, angle, side, and angle, side, angle. And have any questions, feel free to talk to me at any time. And have a great day.